Why does the moon look bigger near the horizon? It's one of those things almost everyone notices at some point. The moon rises, sitting low near buildings and trees, and it looks enormous. Then later, when it climbs high in the sky, it suddenly seems smaller, even though it hasn't actually changed size at all. So what's going on? Is the moon physically stretching near the horizon? Is the atmosphere magnifying it? No. The real answer is more frustrating. Your brain is tricking you. But not randomly. There's structure to the illusion. First, the important fact: the moon's actual angular size in the sky barely changes as it moves from horizon to zenith. Any tiny variation is due to distance changes in its orbit and atmospheric refraction. But these effects are too small to explain the dramatic difference you perceive. So if the moon isn't changing, the only thing left is perception. And perception is where things get interesting. Your brain does not measure the sky directly. It interprets it using assumptions about distance, scale, and perspective. Exactly like it does with objects on Earth. When the moon is near the horizon, your brain sees it alongside familiar reference points: trees, buildings, mountains, even people. These objects provide a depth framework. The brain automatically assumes the sky is a kind of dome, where objects near the horizon are farther away than objects overhead. This assumption is the key. If your brain thinks something is farther away but it still looks the same size, it compensates by scaling it up in perceived size. So the moon near the horizon gets mentally inflated. It doesn't actually grow. Your brain interprets it as larger because it believes it is farther away while maintaining the same retinal image size. But when the moon is high in the sky, there are fewer reference points. It's surrounded by empty sky. Without strong depth cues, your brain doesn't apply the same distance-based scaling, so it appears smaller by comparison. This is known as the moon illusion. And it's not fully explained by a single mechanism, but the dominant idea involves perceived distance scaling combined with contextual visual cues. There's also a secondary factor that strengthens the illusion. The horizon moon is easier to compare with objects. When you see it next to trees or buildings, your brain can directly contrast sizes. This makes its large appearance more noticeable. When it's high in the sky, there's nothing to compare it to. No reference frame, just darkness. So even though the physical image on your retina is almost identical in both cases, your interpretation changes drastically depending on context. There's another subtle layer too: eye movement and attention. When the moon is near the horizon, you tend to look at it in a more land-based visual mode. Your brain is still anchored in terrestrial perception, distance, scale, perspective lines. When it's overhead, your visual system switches to a more abstract sky interpretation where those same scaling rules are weaker. So the illusion is not just visual, it's cognitive. But here's the most important point that breaks the mystery completely. If you take a photo of the moon near the horizon and compare it to a photo of the moon high in the sky using the same zoom level, they are the same size. Cameras don't apply brain-based size correction. They just record light. That's why photos often feel wrong compared to what we think we saw. So the moon isn't changing. Your brain is. And it's doing exactly what it evolved to do: interpret size and distance using Earth-based rules that work extremely well for everyday life, but fail slightly when applied to something as distant and scaleless as the night sky.